Assalamualaikum, my name is Muhammad Amirullah bin Syahri as Group Leader.
Assalamualaikum, my name is Nurul Nasra binti Iman.
Assalamualaikum, my name is Nurul Natasha binti Hairul Anwar. First of all, I will present the abstract of this research. Klein-Gordon equation is solved by using Daftar-Geji and Jafari method, although in some particular research, it has been solved by modified DGJM by Yasin and Samrais in 2012. Thus, DGJM is proposed to solve linear and non-linear Klein-Gordon equation. The results are compared with the exact solution of Adomian decomposition method and variational iteration method, which were implemented before finding the solution of Klein-Gordon equation. Based on the calculation and error analysis, DGJM can solve certain type of Klein-Gordon equation with a high degree of accuracy and efficiency.
Next is the introduction part. The Daftar-Geji and Jafari method is a numerical analysis which was introduced in 2006 by Bashar Daftar-Geji and Hussein Jafari. It can be applied to various types of equations such as ODE and PDE. For instance, DGJM solved the problem of Fisher's equation. Then the solution was compared with ADM. As a result, DGJM is a simpler method without computing any polynomials to solve the problem. Klein-Gordon equation or Klein-Gordon, it was proposed by Klein and Thorpe. The equations plays a crucial role in mathematical physics in examining the nonlinear equations, understanding the interaction between solutons, and condensed matter physics.
Next, problem statement. Klein-Gordon equation has been solved by modified Daftar-Geji and Jafari method. Hence, this research is done to solve and evaluate the accuracy, efficiency, and suitability of basic DGM towards KGE. Next, objectives. The objectives are to solve KGE by DGJM, to approximate the accuracy and efficiency of DGM with other methods, and to verify the suitability of DGM on KGE. Next, the scope is to focus and solve KGE by DGM, while the significance is to verify suitability and compatibility of DGM with KGE with other methods such as ADM and VIM.
Next is literature review of Daftar-Geji and Jafari method. In the article by Abdullah and Slamat in 2015, DGJM has been demonstrated on Fisher equation in obtaining the power series solution. DGJM is applied to clarify linear and nonlinear functional equation and processing both linear and nonlinear ordinary and partial differential equation of integer and fractional order. Ribas Taba and Wright in 2015 has proposed new mathematical model for oxygen delivery through a capillary to tissue. Adomian decomposition method and Daftar-Geji and Jafari method have been used to solve multi-term fractional diffusion equation and showed the findings are completely in agreement. In the other research by Al-Jawari in 2016, DGJM and VIM is implemented to solve Fokker-Planck equation to obtain analytical solution. The result obtained indicate that DGJM is effective and efficient technique for obtaining the exact solution.
Next is a literature review for KGE. In a previous study by Yusuf and Mahmoud, it was proven that VHPM is effective for solving KGE. Besides that, the nonlinear one-dimensional of KGE has been solved by Rashidina, Gassani, and Jalilian using the cubic B-spline collocation strategy. In other research conducted by Khan and Aruna, they presented a divisional transformation method for solving 5 numerical examples of KGE.
Next, methodology. The flow chart starting from understanding the basic idea of DGM and solve KGE by implementing DGM. It is then performing error analysis and making comparison between DJM with ADM and VIM. The form of DGJM is shown in the slide. By applying DGJM, the series term is obtained. Next, implement DGJM to KGE and the series term of KGE is obtained as shown. Validation process is done by making error analysis of exclude error. The comparison is made between DGJM with ADM and VIM.
There are 4 types of problem discussed in results and discussions. For problem 1, the equation is a nonlinear and non-homogeneous with initial conditions and exact solution. By using DGJM, the iterations were obtained. The comparison is made between DGJM and exact solution for various values of t. For t equals 0.8, 0.9, 1 and x between 0 to 1, it can be concluded that the value of t should be smaller to solve problem 1. For problem 2, the equation is a nonlinear and non-homogeneous with initial conditions and exact solution. By using DGJM, the iterations were obtained. The comparison is made between DGJM and the exact solution for various values of t. For t equals 0.3, 0.4, 0.5 and x between 0 to 1, it can be concluded that the value of t should be smaller to solve problem 2.
Next, for problem 3, the equation is nonlinear homogeneous with initial conditions. It has the closed form solution obtained by use of glue in 2008. By DGJM, the iteration were obtained. The comparison is made between VIM, ADM, and DGM for various values of t. For t equals to 0.1, 0.2, 0.3, and x between 0 to 1, the value of uxt of DGJM is close to VIM and ADM.
Problem 4 is linear and homogeneous Klein-Gordon equation with initial condition and exact solution. This equation has proposed by Yusuf Oglo in 2008. By DGJM, the iteration were obtained and it is indeed the exact solution for this problem. DGJM is the simplest and efficient method to solve problem 4 compared to problem 1, problem 2 and problem 3 because it achieves the exact solution.
In conclusion, the objective to implement DGJM on KGE is achieved, which solve 4 different types of equation. The second objective is to approximate the accuracy and efficiency of DGJM. Other methods is also achieved. The focus is on approximation when compared with ADM and VIM. The third objective is to verify the suitability of DGJM on KGE. 4 different types of equation are suitable to solve for small value of t and some value of x. Problem 4 is the best equation to solve by using DGJM. In future researches, it is recommended to modify DGJM in other KGE to achieve the exact solution. Besides, DGJM could also solve 2-point boundary value problem such as Thomas Fermi equation for application in nuclear physics. Thank you.